Okay. Well, we have our homework due tomorrow, so I'm hoping you'll have a little bit of time in class today, especially since we are not doing the normal distribution by hand. You'll need the calculator in order to find those values, so I do want to give you some time. But also, the test on Monday, it's going to cover a variety of topics. Hey, thank you. Luis. Okay. There you go, sir. So it's going to cover the standard deviation we've been talking about. It's going to have normal distribution on there. The correlation coefficient will be on there. So again, uh, this test is more geared towards knowing, again, the technology, even though we have been talking about how to do this by hand. And I did throw a review problem on there. What was that? Cumulative frequency curve. There you go. So you'll remember IQR and all that good stuff in order to figure those out. Okay, so before we go ahead and continue with what we have here, let me go ahead and get a little blank spot. Just a quick review. We've been talking about the correlation coefficient R, and this was a value that described the strength or the weakness of a relationship that my quantities may or may not have. And remember, I said may or may not have because we also talked yesterday, it's very important. Just because there could be a very strong correlation, does that mean there's a causal relationship between them? Okay, no, definitely not. In fact, I showed you the example, I think it was of students with large feet having good reading skills. Yes, just because you have a large foot does not mean you're going to be an excellent reader. Maybe in some people's cases, yes. But we were using three formulas when we were doing this by hand. One was the covariance, S sub xy. Does anybody remember what that formula was? Now remember, these are going to be provided to you if you are going to use them, say, on the paper exams. But just see if anybody remembers it. Emily, what you got? Okay, so the summation. Okay. Okay, the number of terms in your sets, the quantity, yes. If I'm going to have you do anything by hand, I'll probably have it displayed on the board. Okay. So, I mean, it would be good if you committed to memory. I think it'll be better in the long run, but no, I'm not going to really require that you memorize it because, like I said, on the exam, you're not going to need that anyway. Yes, ma'am. That's kind of a lot to unpack in one question. Um, Well, the S sub x and the S sub y represent the standard deviation for each of your two individual sets. The S sub xy is what we refer to as the covariance. That's a value that we have working off each of the sets. Now remember, the value that we have, like say we have standard deviation, what would happen if I squared that? It'd be the variance. Okay, so we have a numerical value representing the variance for each of the sets in essence. So, I mean, as far as a real world application, we've been seeing several examples so far. One where we were taking the time to boil liters of water and how much in minutes it would take. What's the current example that we're on? Does it actually, I think it just gives us a couple of sets. Did the previous one provide us with anything? And it really just depends on what it is you're comparing. I mean, maybe you're talking about a population in a certain time frame, or I don't know. Anything else coming to the top of your head? I'm actually kind of drawing a blank. No? Okay. But I mean, there are several real world examples. Right now, we're just kind of focusing on the data itself. So I don't know if that kind of answers your question. Oh, why would someone need this? Well, because data is only useful if we can do something with it. So when we analyze data, we're trying to take the observations that people have taken the time to bring in, and we're wanting to see, okay, can I make a prediction on this? Do I see any patterns that maybe could come out of this? I mean, you see it all the time. Like we were just talking during our lunch in politics. Okay, people analyze data brought in through politics, so maybe approval ratings, okay, or just polls of people. You see it on television. We did a poll of so many people are in favor of this proposition versus the other one. So it is very useful. So we take the data and we do want to go ahead and do something with it. And what I'm trying to say here is that with the scatter plot, sometimes that's not always the case because maybe it's so weak, there's no relationship at all. So I don't know if that kind of helps. I kind of felt like I got around the problem a little bit. Meh. Okay. But yes, there are a lot of uses for these. We do use these a lot. Okay, so let's see, where was I? Right here. Okay, so that was my covariance formula. Okay, thank you, man. Now we had S sub x and S sub y, which I said was the standard deviation for each of my two sets. So we know we're taking the square root because once we square it, then we have the variance. But what was the formula for the standard deviation of the x's? Eli?
What is it? Sigma.
Okay, so we do have another ratio.
Yeah. What's that simple formula?
Sigma.
Sigma. Okay. It'll be the open parentheses x minus theta of x.
There you go. Okay. Standard deviation for the x set. And Zoe, do you know what the last formula would be? There we go. Okay. So you were to calculate these three, by hand, or at least get as much as you can from the table before some point the technology is going to take over. Well, how would these three interact with each other to give me Pearson's correlation coefficient? Okay, Spencer. There you go. So you take that covariance and you divide it by the product of those standard deviations. Okay. So that is what we've been currently working on. All right, we've already seen, examples by hand. I've shown you by the calculator as well. And in fact, we were right in the middle of this one when class ended yesterday. So I've only got 4 more rows to go. Who wants to come on up and help me fill out the information for 9 and 7? We've still got the mean up here for both the sets. Okay, we just need to fill in basically the rest of it. Gabby, did you come up yesterday? You did? Who did not come up yesterday? Or let's do this. Who did come up yesterday? Okay. Libby, did you come up too? I don't remember seeing you. So are you saying you want to come up for this one?
That's okay. I'll do something else.
Okay, so maybe on the last row. Let's see. Okay, all right. So, Gabby, you're still wanting to do it? You know what? I'll never turn down a volunteer. Here we go. Okay. So we decided to go ahead and round it to 1 decimal place. Okay, so the first thing we need is to take x minus its mean, square that, y minus its mean, square that, and then get a product. Okay, which the calculator can help us with on all of those. Well, not necessarily all of them. Okay. But there we go. 9 minus the 7.875. And I got 1.26, so 1.3 is perfect. And then 0. Okay. That's right. And then that one would be 0 because that's the product. Good. Okay. Well, I'll tell you what, let's go ahead and make it interesting. Since, there's too many people raising their hands for me to possibly choose who could come up and do this. So, Gabby, why don't you just say who you would like to come up and do 10-9 now? Now we're going to find out who our friends are. Okay. Me? Oh, I've already done one. Oh, she got me on that one. Okay. All right. Then I will go ahead and fill in one of these right here. So let's see here. So if I take 10 minus the 7.875, I got 2.125. Then if I go ahead and square that, now I got 4.5156. So I'll just go ahead and say 4.5. Would you guys agree? Okay. And then I'm going to go ahead and take the difference of 9 and 7. Well, that's just 2. Squaring that's going to give me 4. And then the product of those differences there, the 2.125 times 2, I got 4. I can't read my number. I don't know if that's 7.5 or 2.5. 4.25. Can't read my own writing. Okay. There we go. So does this mean because I did the row, I can now choose whoever I want to come up?
Yes.
All right. Oh, Samir, are you? All right. Hey, volunteering. Now, because he volunteered, does that mean I still get to pick after him? No? Oh, that doesn't seem fair. All right. So we've only got 2 left. So the question is, who's going to do this after Samir? And we might want to go ahead and start doing this. You know, we've only got 2 rows, so we need to start working on our totals here. Okay, for certain columns so that we can figure out. You already got that too? Wow, Gabby's on the ball. All right. So he has, is that a...
So that's 3.1.
Okay, that's what I got.
And 9.7 rounding.
Perfect. Okay. Then we have 3. Okay. That's exactly what I got. $9.375. Perfect. Perfect, perfect. We got 1 row to go. Okay, so Samir, who would you like? I guess you were the last one to go, so you get to choose.
You like?
What? I didn't even look at you and so
Not making eye contact. There we go.
Perfect. I haven't done this yet, so it's no guessing.
There we go. All right.
Let's do this. So we got 15.
Yes, we got 15 and 11. So first we need 15 minus 7.875. Okay.
And we just square it.
Squared.
58.77.
Mm-hmm.
They have 11 minus 774. And then we
Multiply the difference, the 2 differences we have. Yep.
so multiply those two, right?
The 7.125 by 4.
Oh, my bad.
Okay. All right. Good, good, good. Nice. Now we just need to go ahead and get our totals. We can go ahead and start figuring out what these values are going to give me. Okay. So, all right, Gabby, what'd you get for that square difference of the x's here? 125? Okay. I got 124.87, so 125 will work out. I think that's perfect. Okay, has anybody got the other total? Somebody else? Evelyn, you're saying 56? Okay. Do you guys agree? Okay. The 16, 9, 1, 1, 4, 9, and 16. Okay. And what are we getting for the last total? Okay. What are we getting? 80.975. So would you guys just want me to put 81? Okay. Ours is not going to be perfect because you'll notice in some places we are rounding to 1 decimal place. Some people were rounding to 2. So it's not going to be exact what we get in the calculator, but it should still be, as I say, in the neighborhood. Okay. Well, let's see what we got here. Let's go ahead and figure out the covariance. So we've got the sum of the product, okay, which is going to be 81. Now, how many terms did we have? Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 81 divided by 8. Let's go ahead and get a decimal because I'm going to go ahead and do this in the calculator now. So 81 divided by 8. Okay, so there's my covariance. Is that what you guys are getting?
Yes.
Do you agree? Okay. Now let's go ahead and figure out the standard deviation for the x's. So we've got the sum of those square differences. We got 125. So I'm looking for the square root of 125 eighths. Okay. So the square root, control divide, 125 eighths. Okay. So the standard deviation for the x's, I'm getting 3.95.
Yeah.
Okay. And finally, I want the standard deviation for the y values, which is going to be the square root of the sum of those square differences, 56 divided by 8. Okay, well, this one's actually nice. What's 56 divided by 8? 7. So we'll just say the square root of 7. Okay, square root of 7. Oh, oh yes, that's why I'm going to go ahead and put it in. The square root of 7, if it'll let me type it in. There we go. That's what we got. Okay. Now remember, the correlation coefficient is going to be the covariance, this top value, divided by a product of the two below. So let me go ahead and do this. It'll be a lot faster. Okay, so enter, and I'm going to go ahead and hit times. I'm going to go ahead and get that product. There we go. So I'm going to take this covariance, and I'm going to go ahead, whoop, want to make sure I hit divide before I go ahead and put that in there. And I'm going to go ahead and divide it by this one right here. Okay, is that what you guys are getting? Yeah, I got close to 0.97. Okay, how are we doing? All right. Okay, well, let's go ahead and do this then. We've worked it by hand. Now let's see how close we were when we were rounding. Okay, so you guys are going to walk me through this. I'm going to go back home. How do I even get to where I put my data in? Okay, so list of spreadsheets. I'll go ahead and click 1 for a new document. We want list of spreadsheets. Okay, now we do have to title these columns here, so I'll just put in X and Y. Okay, what do we always avoid? Yes, avoid that equals row. All right, so let me put in my data, which is 2, 4, 5, 7, 9, 10, 11, and 15. Okay. Now if I hit Control 7, takes me right back to the top, where I'll put in 3, 4, 6, 6, 7, 9, 10, and 11. Okay, so I've got my data in. Now what? Go to Menu, Statistics, Stat Calculations. Okay, now we are comparing two different sets. So this time we have two variables. Okay, now the X and the Y list, we want to go ahead and put in the headings that we just previously typed in. We don't have a frequency list, so we're going to get rid of that. And it looks like all my information is going to show up in D. All right, well, let's see here. The mean for the X's was 7.875. What did we get for that standard deviation on the X's? About 3.95. Okay, that's exactly what we got here. Good. Let's see. The mean for the Y's was 7. That's what we were working with. What did we get for the standard deviation on the Y's? Okay. Right here, I'd say about 2.65, so that's, again, really close. Now, overall, we ended up with about a 0.97 when it comes to the correlation coefficient. So I'm going to come on down here. Boom. There we go. We are. Now, again, it is lengthy. I mean, there are a lot of places where you could easily make a mistake, but, okay, especially if you're working with the table, it just organizes everything for you so much easier. You can just then plug into your formulas and you're good to go. Okay. You know, we've worked by hand. I'm okay with you using the technology. Now, I want you to still be able to do it by hand. We might have a focus activity or some kind of exit ticket where I go ahead and have you do that. But I'd say on the homework for the practice, ultimately, you need to be really good with the technology for the paper exams because they're not going to have you do this on the exams. Okay, and then of course at the end it'll give you the box and whisker plot information for both sets. Okay, all right, so that is all I have. That's the end of correlation. Are there any questions? Hey. Oh, okay. Let me go ahead and show you very quickly. Now, if you're going to... Yeah, go ahead and sketch that part by hand. But, yeah, just set up like a horizontal and a vertical axis. It's going to be in quadrant 1. So, you know, whatever your values are, just choose a range that'll work with those. Like, I think even one of the problems says specifically to make your interval between 60 and 90. I think that's on one of those problems. Yeah. Okay. But showing you in the calculator is actually what I'm going to do as part of the next lesson for the linear regression. So I can absolutely show you now if you want me to, but I'm showing 148.
Okay, so you want us to
I'd say if you for the scatter plot, just draw it by hand, so you're just plotting points. So that's perfectly fine. But as far as finding the correlation R, technology is okay with that. I'm perfectly fine with that. Okay. So good question. Anything else? Okay. Then let me go ahead, shut this